We have been looking at enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in. Prior to this, we have looked at multiple ciphers, for example, different transposition ciphers. We have also looked at some substitution ciphers which enhance the Caesar cipher with that we do in the class. Now in this video and the next few videos, we are going to change our direction a little bit. We are going to start looking at the problem of breaking the enemy's code. Now recall, in the class we create a scenario where we say that, okay, look, all this technology we developed ended up in the enemy's hand. Now enemy is trying to use this technology to sort of communicate with each other, and we just observing the enemy's messages must somehow crack the code. So what happens is enemy starts with a plain text message, a secret code, which is in our project a 10-digit, let's say, sequence. So enemy sends it through one of these encodings and then also sends it to a Caesar cipher with a randomly chosen shift. Now observing enemy's message, we must crack the code, and what helps us, what gives the enemy away, is the fact that there's a header in the message, and it turns out that this header in the class project is always a 6-letter word called Python. Now, we can generalize this situation quite a bit, and that's what we are going to do in the next few videos, because it's quite interesting, programming exercise, as well as makes us think in many different ways. We can, for example, pick up the header randomly from a list. So, enemy need not use always say Python, but in fact may pick this up from a list. Now, again, there are two subclasses here. These headers may be of the same length or maybe of unequal length, and each of these gives rise to its own, let's say, details, which we'll look at. In fact, enemy can then also choose not to place the header always at the beginning of the message, but perhaps at the very end or say somewhere in the middle. So again, in order to crack this code, we need to now know, well, what was the header chosen and how long was it? Also, we need to know where inside the message is this header, right? So we can't assume that's coming in the beginning. We got to figure out all this. But of course, we are going to assume that the list of headers is, let's say, known at the receiver. Just like Python was known at the receiver, we assume that we know this list of headers, but we know that enemy is choosing randomly from this list. Now, this could be quite large. So, it takes some work to, let's say, do all this. First thing first, let us enhance the enemy encoder with equal length headers placed in the beginning. So we say that, okay, look, enemy is not using always say Python as the header, but in fact, enemy is picking up a header from this list, which is called a header list in my case, and enemy randomly picks up a header from this. Now this random choice makes you pick up any one of these. Now notice here, these headers are all of 6 characters equal length. Now we later on, like I said, we relax this requirement, but it's good to just do this and understand how we can build this code. In fact, let's just do it right now. So enemy no longer picks up a single header Python. In fact, we create a header list, or let's say call it headers list, and we, for example, here list down say Python, say cobras, and perhaps say snakes. So enemy is going to pick up anyone randomly from this, and the way I do that is by using, instead of assigning enemy to, let's say, header to just one these strings, I just say random dot choice, say headers list. Now what does random dot choice do? Well, it's a method in the random module which allows us to pick up any one item from this list. And in fact, this is all I need to do from the enemy encoding point of view, and we can see this in action right now. Let's say I run my code, I get my message. This time it happened to be Python, and that's why I could crack it. Let's just try it a few more times. Notice this time enemy is sending something else because we are unable to decode, unable to crack the code. And if I look at message, it's indeed a different header, which is snakes. Like I said, this list could be very long, an enemy picks up randomly from this list. In this case, the enemy's header happens to be cobra. So this is being randomly picked up, and it's quite interesting. Now let's think about how can we break this code. In fact, this is not hard at all, because like I said, we assume that the header list is known on the other side, which is, we have this header list available. So all I need to do really is that, previously I was looking for, let's say, 0 to 6 to 1, which is start stop step, for a list, for a string called Python. What I can do is that, well, I'll ask myself a question that instead of looking for Python, I could look for, let's say, Python, cobras, snakes, which means all the elements of this list, header list. In other words, I can write this a little bit differently. I can just say, instead of looking for a specific string, let us just find out if this particular part of the string is inside the list headers list, right? So now this will do the job because really that's what we are doing. We are finding out if the first six characters in this case are inside this headers list. Now you might wonder why six? Well, in this case, my headers are always six, but that need not be the case. So let us generalize that. Let's say I say, okay, look, header length, HEADER, say len, is equal to length of headers, say 0, right? So again, so it has to be headers list 0. Now basically what I'm doing is I'm saying, okay, let me not assume there are six characters. It could be any length, and I find that by finding out the length of the first character, because for now I'm assuming that these have all equal length, right? So I can make this more general. I can go and say, look, instead of putting a 6 over there, I'm going to say it's going to be header, header len. And also my secret message must start after the header. So I again go and put, say, header, let's say, len over there, right? Now, so that will be my secret message. And in fact, that's all I need. I just need to repeat this in all four. So I just go and say, for example, say header, len. And once again, instead of checking for Python, I'll just go and check, say, in headers list, because I must do it for all the four encodings that are available to me right now. I do the same exact thing here. So over here, it becomes message decode EO, HEADER, len. All right. Um, and same way over here. So I say HEADER len in, let's say, headers list. In, say, HEADERS list. And, I just go and make this, say, HEADER, say, len, stop of like all the way to the end, and read off the message. So I say HEADER, say, len. Again, I say in headers list, in headers, say, list. And over here, I go and read, say, HEADER, len, all the way to the end, right? Now, this will in fact do the job for me. Although, as we'll see, this code can be improved significantly, and we'll come back in the next video to do it. But let's see this working, how this works. Notice now, regardless of what the secret code is, and we can see this, sorry, regardless of what the header is, the code will get broken. And this time, it just so happened the header was Python. And indeed, I managed to break the secret code. That is not a surprise because that's what we have started with. But let's just take a few more examples. So let's say, okay, this happens to be Python again. Let's say here, okay, this is again Python. Okay, so now notice, look at this case. In this case, my message was snakes something, which means this was my secret code. And indeed, I managed to find that out. And this is really not a surprise because all we have done really is to make this a little bit more general. And we are picking up this encoders from a list, which is known on the other side. Like I said, we can further generalize this and we will do that. But before that, we will come back to this, think about it a bit more carefully and try to make this code a little bit more general so that the code becomes more flexible. I hope you found this interesting. In general, if you think this way of learning appeals to you, do look at our website because there are many, many such activities from which you can learn a lot about Python programming. Take care. Thank you so much. Bye-bye.